Hello everyone, this is the third video for inverse trigonometric functions. In the previous two videos we introduced the six inverse trigonometric functions, followed by looking at the range of the six inverse trigonometric functions. So the six inverse trigonometric functions are sine inverse x, cosec inverse x, tan inverse x, and cos inverse x, sec inverse x, and cot inverse x. And now we know, I'm assuming that you've already watched the first two videos and you are aware of the range of those six inverse trigonometric functions. Alright, now we will look at some of the important properties of inverse trigonometric functions. So please write the properties of inverse trigonometric functions. These are very simple properties of inverse trigonometric functions. In order to remember these properties, we must know the range of these functions. So the first property is sine inverse sine theta. If you ever come across sine inverse sine theta, then this will be simply equal to theta. But this is only true if theta belongs to the interval minus pi by 2 to pi by 2, and it must be the closed interval. You will realize that this is the same interval which is actually the range of sine inverse function, right? Sine inverse sine theta is equal to theta if theta belongs to this interval. The second property is cosec inverse cosec theta. Cosec inverse cosec theta is equal to theta if theta belongs to minus pi by 2 to pi by 2 except 0. हमारी जो थर्ड प्रॉपर्टी है वो है tan इनवर्स tan थीटा इज इक्वल टू थीटा इफ थीटा बिलोंग्स टू माइनस पाई बाय 2 टू पाई बाय 2 ओपन इंटरवल, माइनस पाई बाय 2 टू पाई बाय 2 ओपन इंटरवल. फोर्थ प्रॉपर्टी है हमारे पास cos इनवर्स cos थीटा. cos इनवर्स cos थीटा इज थीटा इफ थीटा बिलोंग्स टू 0 to pi closed interval. The fifth property is sec inverse sec theta. Sec inverse sec theta is equal to theta if theta belongs to the closed interval 0 to pi except pi by 2. So we'll eliminate pi by 2 from this range. And the last property is cot inverse cot theta. Cot inverse cot theta is equal to theta if theta belongs to open interval 0 to pi. So if you remember the range of these inverse trigonometric functions, it will be very useful to you to remember these six properties. So whenever you are saying that sine inverse of sine theta is equal to theta, please make sure that the theta lies in this particular range. Otherwise we'll have to do some adjustment to bring it in this range, and then only we can use this property. Alright, now let us look at few questions to understand how we apply these properties. Alright, so let's say I ask you the value of sine inverse sine pi by 3. So whenever you come across such a question, always think about this property, that we know that sine inverse sine theta is how much? It is equal to theta if theta belongs to minus pi by 2 to pi by 2, and this is closed interval. Now if you look at pi by 3 is how much? It is 60 degrees. And what is this? This is minus 90 degree. If you imagine a number line, so this is minus 90 degree and this pi by 2 is 90 degree. So basically आप देख पा रहे हैं कि जो pi by 3 है, this is 60 degree and 60 degree lies, this is 0, 60 degree lies in between this range. It lies in this range. So we can very much apply this property and we can say that our answer will be pi by 3. So sine inverse sine pi by 3 is equal to simply pi by 3. Alright, let us look at one more question here. Let's say the question is asking you tan inverse tan pi by 4. Now what is the property? The property is tan inverse tan theta is equal to theta if theta is lying between minus pi by 2 to pi by 2 open interval. Of course pi by 4 is 45 degrees and 45 degree lies in between minus 90 degree and plus 90 degree, right? So by this we can say that it satisfies this criteria, and hence what is the answer? The answer will be pi by 4 by using this property. So this is how we use this property. Now let us look at another example. Let us say they are asking you sine inverse of sine 2 pi by 3. Sine inverse of sine 2 pi by 3. What is the value of sine inverse sine 2 pi by 3? Now how do we go about this? What is the property? The property is sine inverse of sine theta is equal to theta. And if this is valid only if theta lies between minus pi by 2 and pi by 2, closed interval. Now let us look at 2 pi by 3. 2 pi by 3 is 120 degrees. 2 pi by 3 is 120 degree. How do we get 120 degree? You can look at it like this. 2 pi by 3 is equal to 2 into 180 degree. Pi is 180 degree upon 3. So this is 120 degree. Now does 120 degree lie in this range? No, it does not, because 120 degree is more than 90 degrees. So can we apply this property here directly? No, we cannot apply this property. The answer will not be 2 pi by 3. So what do? We will need to do some adjustment in 2 pi by 3 in order to be able to apply this property. So how do we do that? So let's look at this. Sine inverse sine 2 pi by 3. We can write this as sine inverse sine. We can write 2 pi as 3 pi minus pi, right? We can write 2 pi as 3 pi minus pi and then whole upon 3. Now here we can distribute these terms. So this would become 3 pi upon 3, which is pi, minus pi upon 3. Pi minus pi upon 3. So this is what we get. Now in class 11th we learned that sine pi minus theta is equal to sine theta. Sine pi minus theta is equal to sine theta. How do we get this? This is basically because of the fact that this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Now what is this? This is pi minus theta. Pi minus theta lies in the second quadrant, and in the second quadrant sine is positive, so we get only and only sine theta. So we can replace this part, we can replace sine pi minus pi by 3 with what? We can replace it with just sine pi by 3. Now we can apply the property, this property we can apply now, because pi upon 3, it lies in this particular range. It lies between minus pi by 2 and pi by 2. So what will be our answer? Our answer will be pi by 3. So whenever you come across questions where the given angle is not in the range specified here, always we'll have to do an adjustment to be able to arrive at the correct answer. Now let us take one more example here. Let us say the question is saying cos inverse cos 7 pi by 6. Cos inverse cos 7 pi by 6 is equal to question mark. What is the value of cos inverse cos 7 pi by 6? So what is the property? The property is cos inverse cos theta is equal to theta if and only if theta lies in between. What is the range? The range is 0 to pi, right? The range is 0 to pi. But does this angle lies between 0 and pi? It does not lie between 0 and pi, because 7 pi by 6, if you calculate it, it will be 7 into 180 upon 6. This will be equal to 210 degree. So this is obviously more than 180 degree. So can we apply this property here directly? No, we cannot apply this property here directly. We'll have to modify 7 pi by 6 and write it in a way so that we can ultimately apply this property. Alright, so cos inverse cos 7 pi by 6. Now let us write 7 pi as 6 pi plus pi. We can write 7 pi as 6 pi plus pi and then upon 6. Now here in the bracket we can distribute the terms to get pi plus pi by 6. How do we get pi? Because 6 pi upon 6 is pi and then plus pi by 6. Now which quadrant is this? As you can see here, it is pi plus pi by 6. That means we will be arriving in the third quadrant because we are adding something to pi. So this will be in the third quadrant. Now this is the third quadrant. So third quadrant, we must know that cos pi plus theta is equal to minus cos theta. And why is it negative? Because in the third quadrant only tan theta and tan theta's reciprocal cot theta is positive. All other trigonometric ratios are negative in the third quadrant. So we can write here that this will be equal to cos inverse cos pi plus pi by 6 can be replaced with minus cos pi by 6. It can be replaced with minus cos pi by 6. Now, what is the value of cos pi by 6? That is cos 30 degree. Cos 30 degree is root 3 by 2. So we put its value and we arrive at cos inverse minus root 3 upon 2. Now, this is the same question that we have done previously in the previous video. What is the principal value of cos inverse minus root 3 upon 2? Now, how do we solve this problem? Let us first assume that what we would have got if this negative sign was absent. If this negative sign was absent, it would have been just cos inverse root 3 upon 2, whose value is 30 degrees, right, which is pi by 6. Now, this belongs to the second basket. What is second basket? It is the basket containing cos inverse function, sec inverse function and cot inverse function, whose range is in between 0 to pi. So, in this situation, we'll have to subtract pi by 6 from pi to arrive at our final answer, which is the principal value. So, we'll write pi minus pi by 6, which is equal to 5 pi by 6. Now, how do we get this pi minus pi by 6 thing? For this, you must watch the second video to understand how do we do this. What is the method to arrive at the answer for cos inverse negative value, sec inverse negative value and cot inverse negative value. So what is the answer of this question? It is 5 pi by 6. Some students may just write the answer as 7 pi by 6 for this question using this property, only this much. But do not ever forget that the property is incomplete if you do not know that theta has got a range associated with it. And what is that range? It is 0 to pi for cos inverse function, right? So always keep this in mind. All right. So these are some of the problems that we have solved related to the 6 properties. Now let us also solve a couple of questions from NCERT exercise 2.2. All right. So exercise 2.2. Let's solve question number 16. So question number 16 is saying sine inverse sine 2 pi by 3. Sine inverse sine 2 pi by 3. I think we have already solved this question. 2 pi by 3 does not lie between minus pi by 2 to pi by 2. So what do? We'll modify 2 pi by 3 and we'll write it as 3 pi minus pi by 3. And now we can distribute it. इसको हम कर लेंगे distribute. तो कितना आ जाएगा ये? Sin inverse sin pi minus pi by 3. What is sin pi minus theta? It is sin theta. So this will be sin inverse sin pi by 3 and the value would be is equal to pi by 3. Using the property sin inverse sin theta is equal to theta, because now this theta lies in between minus pi by 2 and pi by 2. Let's solve question number 17. It says tan inverse tan 3 pi by 4. First of all, let us check whether 3 pi by 4 lies in between minus pi by 2 and pi by 2. It does not lie between minus pi by 2 and pi by 2. So we'll have to modify 3 pi by 4 until it lies in between that range. So we can write 3 pi as 4 pi minus pi like this. So this will be equal to tan inverse tan pi minus pi by 4. Now, what is tan pi minus theta? Tan pi minus theta. Let's understand this part. Tan pi minus theta is equal to minus tan theta. It is equal to minus tan theta. Why minus? Because pi minus pi by 4 will lie in the second quadrant, and in the second quadrant everything apart from sin theta and cosec theta has a negative value. So tan is going to give us a negative value. Now, what is the value of tan pi by 4? Tan pi by 4 is tan 45 degree, which is equal to 1. So this becomes tan inverse of minus 1 when we put in the value of tan pi by 4. Now, this is the question which we solved in the previous video. What is tan inverse minus 1? If we didn't have this minus sign, the answer would have been pi by 4. But with this minus sign, the answer would be minus pi by 4, because minus pi by 4 lies in between minus pi by 2 and plus pi by 2. So this is how we solve these questions. So we have done question number 16 and we've also done question number 17. Now let's look at question number 19. What is question number 19? Cos inverse cos 7 pi by 6. Cos inverse cos 7 pi by 6. Let us try to solve this one. Cos inverse cos 7 pi by 6. Now 7 pi by 6 does not lie between 0 and pi. That means it requires us to do some modification here. We can write 7 pi as 6 pi plus pi and then upon 6. Now if we distribute it, we'll get cos inverse cos pi plus pi by 6. Pi plus pi by 6 is lying in which quadrant? It is in the third quadrant. And in the third quadrant, cos is going to be negative, right? So we'll get cos inverse minus cos pi by 6. What is cos pi by 6? Cos pi by 6 is root 3 upon 2. Cos pi by 6 is root 3 upon 2. So we get cos inverse minus root 3 upon 2. Now, if we did not have this minus sign, the answer would be just pi by 6. But because we have this negative sign and we have to make sure that the answer of cos inverse lies in between 0 to pi, we'll have to subtract this pi by 6 from pi. And we'll get 5 pi by 6. So this is our final answer. I hope you're able to follow what we're discussing here. Alright, so that's all for this video. So we have finished the properties of inverse trigonometric functions to find the values of sine inverse sine theta, cosec inverse cosec theta, cosec inverse cosec theta, tan inverse tan theta, and so on. Alright, thanks for watching. See you next time. Bye.